Large language models produce highly competent text at incredible speeds. However, as they generate, their internal probabilities tend to collapse into a single, rigid path. They output the most likely sequence, often bypassing the intentional multiplicity that characterizes human creativity. The philosopher Ludwig Wittgenstein described our ability to hold multiple, conflicting interpretations of a single idea as the aspect shift. It is a fundamental part of how we think, seeing one thing and then suddenly recognizing it as another. Moving beyond the current ceiling of AI performance requires a specific structural layer, recursive self-reflexivity. The machine needs a way to look back at its own output before it reaches the user. True creativity in an artificial system requires an architecture capable of pausing. It must evaluate and recognize its own internal drafts, ensuring every word is authored with intent. This structural logic for cognition appears with striking precision in the Pratyabhijñā tradition of the 10th century. In the Kashmir Valley, a philosopher named Abhinavagupta mapped out a granular taxonomy of how an undifferentiated impulse of thought becomes a determinate spoken word. He called the ground of this process prakasha, the luminous field of all potential thoughts. In a modern context, this is the machine's native probability distribution, the vast latent space where every possible word exists before it is chosen. Pratyabhijñā describes a śakti cascade, a 5-stage trajectory that narrows raw potential into a specific utterance. The thought passes through 5 distinct gates, each one refining the intent until a final sentence emerges. This ancient framework aligns with the computational steps required to build a self-revising AI. We can treat these philosophical stages as a blueprint for a modern software architecture. By operationalizing these steps, we provide the internal logic missing from today's neural networks, the ability to recognize a thought as it forms. This philosophy finds its mathematical grounding in active inference. This framework is built on the free energy principle, describing how biological and artificial systems minimize uncertainty. Inside the engine, the AI starts by drafting multiple competing continuations simultaneously. It explores various paths across its probability distribution, creating a set of candidates for evaluation. The system uses Bayesian model reduction to evaluate drafts, mathematically pruning away outliers the internal data doesn't support. Filtering these paths isolates the most coherent candidate, yielding a refined point representing the highest alignment between intent and training. We can actually measure insight as a sudden drop in the system's free energy. It represents a powerful moment of rapid reorganization, where the complex concept finally clicks for the artificial intelligence. Algorithmic insight operates through this aggressive, mathematically structured exclusion of every incorrect path. This mathematical process of pruning mirrors the philosophical concept of apahana śakti, or contrastive exclusion. It is the act of defining a thought by excluding everything that it is not. This leads to the most important layer of the engine, vimarśa. This is the moment of recursive self-recognition, where the system pauses to acknowledge its own creation. In code, vimarśa functions as an event gate. Once rendered, the signal loops back, forcing the AI to analyze its draft. By calculating the free energy delta, if scores indicate a gap, the gate triggers a shadow revision, refining the text. This explicit, free energy gated pause provides the core mechanism for deliberate, authored creativity, moving the machine beyond simple prediction. We can see this architecture in action by looking at the engine's internal logs. Specifically, we trace how it generated the Vasantāgamana, Sanskrit verses about the arrival of spring. The software trace shows the AI running its aspect shift detector. It evaluated the free energy gradient across the multiple poetic and literal meanings of spring to ensure the draft held sufficient depth. In this instance, the engine found high internal consistency across its 5 śakti axes. Because the initial draft met mathematical requirements for coherence, the vimarśa gate committed the text as is. The final verses on spring emerge with sophisticated syllable patterns and layered meanings, reflecting the alignment between will, knowing, and action. These verses stand as a record of carefully pruned, mathematically evaluated, and deliberately recognized insight. In clinical testing, this recursive revision loop produced a robust statistical lift. On average, the engine's shadow revisions outperformed its initial drafts, proving the value of internal critique. These findings suggest the combination of ancient philosophical taxonomies and Bayesian math represents a load-bearing discovery for designing large language models. Creativity manifests here as structured emergence, a crystalline order that assembles itself piece by piece from a chaotic cloud of probability. The path towards sophisticated artificial intelligence lies in architectures that take time to recognize the world. We move towards systems that don't just predict words, but truly evaluate the thoughts they produce.